Okay, on this one, we're going to talk about exploring inequalities. These are going to look very similar to what we did before. Here you're going to see we've got two linear equations. And so you put them like we did with equation solvers into this guy right here. All right. And this will tell you where they intersect. So it tells you where they're equal, but it doesn't tell you where the inequality is solved. Now you can do this thing right here where you come back in and you put in the equation just like it is. It tells you here where you find its second math. You'll test second math and you'll find this guy and you can put it in. So now it comes in and we know when we do this that the intersection is at 4 here. Problem is we don't know whether we're dealing with to the left or right. So what this tells us is I'm dealing with all x's that are to the right. And so we're dealing with x which is greater than or equal to 4. I'm going to set some up. So my left side then I'm going to put 2x plus 17. And I'm going to put negative 4x minus 16. I'm just going to copy this in, 2x plus 17. Remember, test and math and phi, it will get you these things, minus 4x minus 16. So when I graph this thing, one of them comes through like this. Here's my intersection, which is at negative 5.5. Which doesn't really tell me anything, but you should have a ray over here and it's pointing in this direction, which means that x is all values which are going to be less than or equal to negative 5.5. We do the same thing over here. I will get a 1.6x minus 2.2. 4.8x plus 7.4, and then we copy it. So 16x minus 2.2 less than or equal to 4.8x plus 7.4. And then when we graph this guy, got one line which looks something like this, another line which looks something like this. My intersection is at x equals negative 3. And then because we have this thing, it showed our ray coming off here. So that tells me it's I'm dealing with all x which are greater than or equal to negative 3. Will satisfy this inequality. Okay, and the same idea down here, 0.5x minus 4.6, negative 2x plus 10.9, 0.5x minus 4.6 greater than negative 2x plus 10.9. When we graph this and find the intersection, I've got a line which comes through like this, and another one which comes through sort of like this. My intersection is at x equals 6.2. But the ray is what we're after. It's pointing off in that direction. So that tells me that x is going to be greater than, but not equal to because of that, 6.2. Okay, take a look at page 2. Trichotomy law. All right, don't let this fool you. It sounds really bad. But all this is really saying is that if I've got numbers, A, B, and C, okay, or if I got two numbers, A and B, then one of these has to be true. Either A is going to be less than B, A is going to equal B, or A is going to be greater than B. And one of these is going to be true. Okay, so here we're going to come over and check this out. All right, so we need to decide which number is bigger. They're both 19, that's equal. The zeros are equal. The 4s are equal. But this 7 is bigger than that 5, which means that this number then is going to be bigger. Okay, now we can do sort of the same idea here. You can combine these, which would be negative 14 and negative 13. And if you take a look at this, you should know that negative 14 is going to be less than negative 13. Another way is that since both of these numbers are the same, you just compare these two numbers. A larger negative number is smaller than a smaller negative number. Okay, on part C, we're probably actually going to have to do some arithmetic. So 22 plus 17 is 39. This gives me 36. Negative 6 squared is 36 plus 3, which is 39. And I know that 39 equals 39. Okay, now the same idea here. So if I know A is less than B, then adding C to both sides does not change my inequality. All right? Same way if A is greater than B. So let's take a look at this. We know that 3 is less than 12. Okay, we're adding 6 to both sides, but that does not change the inequality, but let's take a look at it. So 3 plus 6 is 9. 12 plus 6 is 18. And we know that 9 is less than 18. So let's do the same thing here. I'm subtracting. 14 minus 10 is 4. 9 minus 10 is a negative 1. And I know that since this was true, this is also true. All right? Okay, and on this one thing you think about doing is subtracting 8 over here. Or you can think of 12 as being 8 plus 4. Which means that x then is going to be bigger than 4, which you can either get by solving a one-step equation or not. On this one, if we add it over, we know I'm going to add 4.2 to both sides. So it's going to mean x is still going to be less than 7.2 because I've added the same number to both sides. All right, the same idea if I'm dividing or multiplying. As long as I do it to both sides, it does not change the inequality unless I'm doing it with a negative number, in which case it does switch it. You notice here they're talking about C as a positive number. If C is a negative number down here, then you have to switch your inequalities. In other words, this will switch from less than to greater than. So let's take a look at some of these. So 3 divided by 3 is 1. 12 divided by 3 is 4. And so 1 is less than 4. Now the reason these are important is it tells us we can do our standard algebraic operations on inequalities. Or in other words, you can treat an inequality just like an equality, except if you're multiplying and dividing by a negative number. So 14 times 2, 28. Negative 9 times 2 is negative 18. And this one is still bigger. So over here, what I need to do then is I need to divide by 6 on both sides, which means x is going to be bigger than negative 2. It's because I've divided both sides by 6. On this one, I need to multiply both sides by 3 because that's my denominator. That means x is going to be less than 15. And it doesn't change it because I multiplied both sides by the same positive number. Okay, so 3 divided by negative 3 gives me a negative 1. 12 divided by negative 3 gives me a negative 4. And notice originally we had 3 is less than 12, but divided by a negative, now I'm down the other one, and negative 1 is bigger than negative 4. Same idea here. 14 divided by negative 2 is negative 7. So originally this was the bigger number. And 9 times, I'm multiplying. So 14 times a negative 2 is negative 28. And negative 9 times negative 2 is 18. And so now I know this is the smaller number. So the same thing here. I divide both sides by 2. Usually by negative 6. When I do that, I have to switch this around. So it becomes x is less than 2. So anytime you divide by a negative, you have to switch it. Same way here, I need to multiply by a negative 3 on both sides. So that will give me x is bigger than negative 15. All right. So now let's come in. We're going to solve these algebraically. And then we're going to display them both symbolically and as a number line graph. So 4x plus 15, we treat these things up above here told us we treat these just like equations. So the first thing I do is subtract 15. So I have 4x is less than or equal to negative 20. And now I divide by 4. Because it's positive, I don't have to worry about switching the signs or the inequality. So x is going to be less than or equal to negative 5. And this is your symbolic symbol. Now as a number line, you do just like we did at the beginning of the year. We had to do these number lines. Here's 0. Here's my negative 5. So I know x has to be to the left of negative 5. Okay, it's the same idea here. All right. I want to subtract 3. This is going to give me 3x is greater than 5x plus 2. So now I want to subtract 5x from both sides. That gives me negative 2x is greater than 2. Now I need to divide, but by a negative 2, which means I have to switch this thing. So x is going to be less than negative 1, not equal to. So on a number line, there's negative 1. I will put an open circle and then an arrow going off to the left. Okay, let's take a look at page 3. Same idea here. So let's subtract 6. So it's going to give me 3x over 4 is greater than negative 3. I need to clear my fraction, which means I multiply both sides by the number in the fraction. So that gives me 3x is greater than negative 12. And now I'm dividing by a positive number, so I don't have to change it. So x is going to be bigger than negative 4. There's my symbolic on the number line. Here's negative 4. It's open. X is going to be bigger than that, so it's going to be this way. Okay, number 7. Treat these just like equations, so I have to clear my grouping symbols. So I'm going to have negative 2x minus 2x minus 10. It's going to be less than or equal to 2x minus 8. And I'm going to simplify, so I get a negative 4x minus 10 is less than or equal to 2x minus 8. Alright, so I add 10. I get a negative 4x less than or equal to 2x plus 2. Then I subtract 2x. Gives me negative 6x is less than or equal to 2. And I have to divide by a negative number here, which means I have to switch that. And it's a negative 1/3. 2 over 6 reduces to a negative 1/3. So same idea, if this is 0, this is 1. So I come to about where negative 1/3 would be, and x is bigger than that, which means it's going to be over in this direction. Okay, number 8. Alright, I don't have any fractions to clear, but I can simplify, so I have 2x is greater than 2x plus 1. So I subtract 2x. This becomes 0 is greater than 1. This is false. 0 is never bigger than 1. So there are no solutions. Because my basic inequality is false. So over here, let's take a look at this guy. I clear my grouping symbols. Subtract 6. I have 3x is less than 3x plus 2. I subtract 3x. So now I have 0 is less than 2. This is always true. So your solution is all real numbers.